Hello dear students, now I am continuing the exercise 13.3 second questions. In the previous class we have already studied about Bayes theorem, total probability theorem. So here the questions from exercise 13.3, just you have, I think all of you are done the example also in your copy. So just here second question, very important theorem, Bayes theorem. Just 6 marks questions also asked from this topic. Okay, so here just we will discuss about all questions one by one. Just you have to write in details in your answer, but here just I am only giving logically description and will write in very short. Okay, so here a bag contain 4 red 4 black balls, another bag contain 2 red 6 black balls. Red and black, two bag are there. One of the two bag is selected at random and a ball is drawn from the bag which is found to be red. Find the probability that the ball is drawn from the first bag. Okay, so our experiment results is what? Red ball is getting. So what is the probability that the ball is drawn from the first bag? That is reverse probability. Just for solving these questions we have to use what? Bayes theorem. Okay, so here just for Bayes theorem we know that E1, E2, E3, En, some events which constitute partitions. So here just two events are there because two bags are there. First bag contains, second bag contains. So solution of second, what? Just we have to make two events, selecting first bag, selecting second bag. Okay, so here writing, main thing is that just understand what is given in the questions. In these questions just we have to find reverse probability. For that just first bag contain, second bag contain, this first bag, bag 1, bag 2, okay, this is bag. Okay, first bag contain how many balls are there? Just 4 4 2 6, 4 4 2 6, red black, red black, red black. Okay, red and black balls. Okay, two bags are there. Just we have to denote events E1, E2, events A. So here just let E1, E2 and A. E1 selecting bag 1, selecting bag 2. A red ball is drawn. Just red ball is drawn. Red ball is drawn. Okay, just we have to denote first events. Then just we have to find what is the probability that red ball, that the drawn ball red is from the first bag, that is red already happened and first bag means E1. Just we have to find this P E1 by E and use this theorem formula. For using this formula, just we know what same value E1. So here E1 into P A by E1 upon total probability. Just same thing for all events. Just P E1 dot P A by E1 plus P E2 P A by E2. This is our main result. For finding this, we require PE1, PE1, PE2, PE2, PA by E1, A by E2, PA by E1, A by E2. Just find these probabilities and put the value here. This then. According to given question, PE1. PE1 means what? Selecting bag 1. PE1 means probability of selecting bag 1. 2 bags are there. So selecting bag 1 is what? 1 out of 2. So 1 by 2. Also PE2, what? Selecting bag 2 out of 2, 1 by 2. So both are 1 by 2. Now PA by E1 means what? Probability of getting red ball from E1 means first bag. From first bag. Because here what is means? A by E1 means E1 is already selected. So E1 means first bag. First bag. So from first bag red ball selecting what? 4 by 8. So 4 by 8. That is equals to 1 by 2. And also PA by E2. That is from second bag. Selecting second bag. Getting red ball from second bag. 2 by 8. 2 by 8. 2 by 8 equals to 1 by 4. This. So by using Bayes theorem, by using Bayes theorem, the probability of getting red ball from first bag, probability of drawing red ball from first bag, bag 1 is this, by using Bayes theorem. So just you have to denote and set up the questions. Okay. Substitute all the values from here. PE1, E2 means 1 by 2 into A by E1, 1 by 2 upon E1 1 by 2 plus E2 1 by 2 into 1 by 4. Okay, so this is the value. 1 by 2 into 1 by 2 upon 1 by 2 into 1 by 2, 1 by 2 into 1 by 4. So just you can solve it. The answer is what? Just here see 1 by 2, 1 by 2, 1 by 2, just common. So 1 upon 1 plus 1 by 2. 1 upon 1 plus 1 by 2. Okay, this is what? 3 by 2, 2 by 3. So 2 by 3 is the answer. Okay, you can solve it 1 by 2, 1 by 2, 1 by 2, 1 by 2, just taking common 1 by 1 plus 1 by 2, 3 by 2, 2 by 3 is the answer. Okay, 2 by 3, just 1 by 4, 3 by 8, so 2 by 3, 2 by 3 is the answer. So just set off first of all the notation. Okay. Similarly, second question, third question, see here, what? Of the student in a college, it is known that 60% reside in the hostel, 40% are day scholar not residing in hostel. Okay, 60% hostelers and day scholars are 40% students of the college. Okay. Previous year result report that 30% of all the students who reside in hostel attain A grade. Hostelers, 30% hostelers getting A grade, 20% and 20% of day scholars attain A grade. Okay, in the annual examination. At the end of the year, one student is chosen at random from the college, and he has an A grade. That is our event, just A event for notation. Okay, and what is the probability that the student is a hosteler? So here E1, E2, there are two things, hostelers and day scholars. So E1 hostelers, E2 day scholars. Okay, and chosen student is getting A grade is our event A. Just we have to find the probability. If E1 is hosteler, then P E1 by A. That is, our notation will be how? Just take question 3. Okay. Here E1 means students are from hostel. Okay. Student are day scholar. Okay, or not residing in hostel. Suppose E1 means event that the students are from hostel. E2 means students are from day scholar. Students are day scholar. Event. And A. A is what? A is the chosen student gets A grade. A grade. Chosen student gets A grade. This is our notation. Then according to question, probability of E1 means students are from hostel. What percent? 60%. That is 60%. Means 60 by 100. Means what? 3 by 4. We can write it also 0.60. Okay. Similarly, PE2 at what percent? 40%. So 40% means 40 by 100 equals to 0.40. Okay. And also just for requiring, we have to find what? A grades student from hostel. E1 by A. From hostel. Student is a hosteler. Is from hostel. So we have to find E1 by A. So just we require A by E1. A by E1 means what? From hosteler, here it is given that hostel students are getting how many percentage? 30%. Students from hostel getting A grade 30%. So 30%. 30 by 100 equals to 0.30. Similarly, P A by E2 means out of day scholars getting 20%, I think 20%. Okay, so 20%. What? 20 by 100. Just remember it that notation and setup is important. What will be the events of E1, E2 and A? Okay. So by using Bayes theorem, the probability of what is, we have to find probability probability that the chosen student, probability that the chosen student, probability that the chosen student is a hosteler, given that he has grade A. He has grade A. Is given by what? E1 by A. A means with grade A. E1 means from hostel. So this is from base theorem, just same formula. PE1 upon, PE1 into A into P A by E1 upon just same thing PE1 PA by E1 plus P E2 PA by E2. Just put the value, all the values. 0.60 into 0.40 upon, not 40, 0.30. So 0.60 into 0.30 plus 0.40 into 0.20. So this is 4 into 2, 6 into 3 and 6 into 3. Just solve it. You can get the value as 0.60 means what? 0.60 means just 3 into 6, 18, 0.18 upon 0.18 upon, just you can see here, 0.18 plus 0.80. 0.80. That is what? 0.18 upon 0.26. 0.26, 18 by 26. Okay. 18 by 26 means 9 by 13. 9 by 13. So this is the probability. Just set of this notation for given questions. Okay. So Bayes theorem gives the result. Okay. Now take question 4. Question 4 is what? In answering questions on a multiple choice test, student either knows the answer or guess the answer. Let 3 by 4 be the probability that he knows the answer. 3 by 4 probability he knows the answer. 1 by 4 be the probability that he guesses. Assuming that a student who guesses at the answer, assuming that a student who guesses at the answer will be correct with probability 1 by 4. If a student guesses the answer, then to be correct, probability is 1 by 4. What is the probability that the student knows the answer? Given that the answer is correct. Given that the answer is correct. So our event A is, given answer is correct by the student. Okay. So we can write here. Just we have to use here this writing, just write like this. Okay. Question 4. Just we have to set out what? A be the event. A event that given answer is correct. Given answer is correct. And here, just we have to find the probability that he knows the answer, given that the answered it correctly. Okay, here just event to event, he knows the answer, guess the answer. Event student knows the answer. Event student guess the answer. Student guess the answer. Okay. Just this is our setting. Now we have to find the probability. Find the probability the student knows the answer. The student knows the answer E1. Given that he answered correctly. He answered correctly. That is E1 by E1. So we are using Gauss probability that the student knows the answer. Knows the answer. Given that he answered correctly, is given by this theorem, Bayes theorem, PE1 by A. Clear? Just find all the value. PE1, E1 knows the answer, just it is given. Knows the answer, it is given 3 by 4. Okay, it is given 3 by 4, 1 by 4. 3 by 4, PE1. Guess the answer, what? 1 by 4. A by E1. A means correct answer is given. E1 means knows the answer. 1. Sure event. Knows the answer. 1. Because correct answer and knows the answer. 1. A by E2. Guess the answer. And correct answer. Guess the answer. So it is given correctly with probability 1 by 4. So it is 1 by 4. Given in question. Just use these values here. We can get the result. Okay. So this is main thing, that what will be the events for particular questions. Okay. So here just put the value 3 by 4 into 1. 3 by 4 into 1 upon 3 by 4 into 1 plus 1 by 4 into 1 by 4. 1 by 4 into 1 by 4. It can be solved very simply. What? Here 1 by 4, 1 by 4, 1 by 4 cancel out. So 3 upon 3 plus 1 by 4. Just see 3 upon 3 plus 1 by 4 equals to 13. 13 by 4. So 12 by 13. 12 by 13. Probability is 12 by 30. So this is our answer. Okay, main thing is what? Just set off. Okay. So next question 5. Question 5. Okay. A laboratory blood test is 99%. A laboratory blood test is 99% effective in detecting a certain disease. 99% effective in detecting certain disease when it is fact present. If disease is present, then 99% detect. However, the test also yields a false positive result for 0.5% of the healthy person tested. 0.5% gives false positive result. That is, if a healthy person is tested, then the probability 0.005, the test will imply he has disease. 0.005 because 0.5%. So this is the probability when a healthy person is tested and falsely result is disease. If 0.1% of the population actually has the disease, for disease, probability for disease is 0.1%. What is the probability that person has a disease? That is, our event A will be what? Person has disease. Okay. Given that his result is positive. Given that his result is positive. Okay. So just we have to set up what? P1, E2 event here also two things are given. Person has disease and or healthy person has no disease. So person has a disease, has no disease. Given that person has disease, person has disease. What? D-I. Person has disease. First. Person has no disease. And A event. What is the probability finding? Probability that person has the disease given that the result is positive. Okay. So here person has the disease given that. Person has the disease given that A what? His result is positive. Okay. So A be the event, the blood test result is positive. Event that blood test result is positive. Given that result is positive. Okay. Then according to questions, just we have to find what? Probability that the person has the disease. Probability that the person so by using Bayes theorem, the probability that the person has the disease given that person has given that his test result is positive. His test result is given by this formula. Okay, E1 has disease given that test result positive. Now just find the value from the questions. According to questions, what is the value? P1, person has disease 99%. Okay, so person had loss here, not 99% effective test. There is a laboratory test here. 0.1% of the population actually has the disease. 0.1%. So this is equals to 0.1%. 0.1%. That is what? 0.1 upon 100. That is 0.001. 0.001. Okay, and here just we see that has digit, has no digit. That is complementary event. Since here, since E1 and E2 are complementary events, therefore PE1 plus PE2 equals to 1, implies PE2 equals to 1 minus PE1, that is 1 minus 0.001 equals to point what? 999. Point 999. Point E2. PE2 equals to point 999. This. Now PA by E1. A means test result positive and has digit. So what is this? 99%. Okay? 99%. This is 99%. 99 by 100. 99 by 100. That is 0.99. And PEA by E2, that is has no digit and test result positive. What is given that? 0.5%. 0.5%. Okay. 0.5%. That is 0.005. Just use this value now. Okay, U1 by A. Just we see that, put the value 0.001 into 0.99 upon this 0.001 into 0.99 plus just 0.999 into 0.005. 0.005. Just solve it. You can find the value. Okay. What? Just use multiplication and addition and division. So you can get the value as what? 990 upon 5985. 990 upon 5985. 990 upon 5985 equals to 22 upon 133. Just calculate it. You can find its value by removing decimal and multiplying and adding and dividing. Just 22 by 133. 22 by 133. Okay, so main thing is what? Just set up. So this question was what? Fifth question. This was the fifth questions. Okay. Now taking sixth question. The question sixth. There are 3 coins. One is two-headed coin having head on both sides. Another is a biased coin that comes off heads 75%. Biased coin. Coin is not fair. Biased coin. 75% gives heads. Second coin. Third coin of the time. And a third is an unbiased coin. This is fair coin. One of the 3 coins is chosen at random. Just select one coin at random from 3 and tossed. It shows heads. There are 3 coins. Just select one of the coin at random and then throw. Shows head. What is the probability that it was the two-headed coin? There is probability of two-headed coins by shows head. So our A event will be what? Or event A. What will be the event A? Shows head. Okay. So there are 3 events, not E1, E2 and E3 in this question. Question 6. Just there are 3 points. So E1, E2 and also E3. Okay. So for this question, just we have to write like how. Let E1, E2, E3, A. E1. How many coins are there? E1 means two-headed coin. Selecting two-headed coin. Two-headed coin. Okay. There are how many two-headed coin? And selecting just E2 event. Let event, that's selecting two-headed coin and unbiased coin, biased coin, and selecting unbiased coin. and A shows head. Event coin shows head. This. Okay. So we have to find the probability that the coin is two-headed coin, given that it shows heads. Okay. So here just what we have to find? Probability two-headed coin upon shows head. PE1 by A. Just this. For this here our formula will changes up to third part. Okay, here we have to find the value of just our formula will be what? By using Bayes theorem, the probability that the coin is two-headed. Probability that the coin is two-headed. Probability that the coin is two-headed. Given that it shows head, is given by PE1 by A, and here there are three events, so just we have to write the formula up to PE3 into PA by E3. Clear? So according to questions, E1 selecting two-headed coins. So selecting two-headed coins, there are three coins. Selecting any of the coin, just like E1, E2, E3, any of the coins. What? 1 by 3. Three coins, total 3. And selecting two-headed coins, 1 by 3. Selecting biased coin, 1 by 3. Selecting unbiased coin, 1 by 3. Now, three values are here. PA by E1 shows head, two-headed coin shows head. Two-headed coins means both side head. So head will always occur. So probability 1. So PA by E1 equals to 1. PA by E2 biased coin 75% times shows head. So this is 75%. 75 upon 100 means 0.75. 0.75. Just you can write 3 by 4. You can write 3 by 4. Okay. 3 by 4. And PA by E3. Unbiased coin, fair coin, always gives probability for head getting head 1 by 2. 1 by 2. Clear? Now, just apply this formula. So put the value here. So what? 1 by 3 into 1. 1 by 3 into 1 upon 1 by 3 into 1, 1 by 3 into 3 by 4, no, just first value is 1 by 3 into 1 plus 1 by 3 into 3 by 4 plus 1 by 3 into 1 by 2. Okay, just use this formula. This into this, this into this, this into this. So here 1 by 3, 1 by 3, 1 by 1, 3 by 4, 1, 3 by 4 and 1 by 2 and 1 by 3 into 1. So this is the value, just you can solve it. Okay, so see here 1 by 3, 1 by 3, 1 by 3, 1 by 3, cancel out. So upon 1 plus, just you can write like this, 1 upon 1 by 3, 1. Here 1 by 3 common, so cancel out. 1 upon 1 plus 3 by 4. 1 plus 3 by 4 plus 1 by 2. And 2 LCM 4. So here 4 plus 3 7 plus 2 9 by 4. So 4 by 9. So answer is 4 by 9. This is equals to 4 by 9. So this is required probability. Okay. So just here main thing is what? Select notation. Give the notation. Just proper notation. Just give. Then you can set off the bias theorem formula according to the questions and getting probability. Okay. So just solve all the questions from examples also, and remaining questions I will solve in the next class. Okay, just solve, write in details in your copy all the questions and send me PDF file of solution of 2-3 questions. Okay, for your attendance.